Everyone will know this. It's the rectangular hollow plate that we deal with getting started. This is what you'll start with in high school, college, or taking a simulation class. It's a really good introductory part. Shows a few interesting things, but it's very simple. So let's just get started with the most basic type of simulation, a structural FEA, what we call linear static analysis. All that means is it's just very simple. A simple material being used, something very common like aluminum or steel, and it's a single part. Okay, so let's just talk about how we set this up, how we perform a study using SOLIDWORKS Simulation. Now this is the SOLIDWORKS interface here, what you're looking at, right? So it's just a single part with a hole in it. Nothing crazy going on here. And to get started, it's just up top here in the command manager, finding the simulation tab and hitting new study. We do that, we'll be greeted on the left-hand side of the screen with the interface here where we can pick all the different types of simulation types or study types that we can perform based on our licensing. So we're up here at the very top with static under the general simulation option, right? So we can give this a nice descriptive name. I'll give it YouTube study, right? We're here on YouTube, so hit the check mark. The study is added to my interface. How do I know? Well, I see a tab down here at the bottom, similar to something like Microsoft Excel. You run multiple studies, all of them get tabs down in the bottom of the screen. And it's basically like sheets in Excel, right? Something that we're really familiar with. This is nothing out of the ordinary in terms of technology that we're used to using, and that makes it so simple to use, easy to discover and learn and grow after you get a good foundation here. So for those of you who are very used to using SOLIDWORKS, this type of workflow that we're looking at here is something very familiar, right? We have the graphics area in the center of the screen with our modeling environment, and over on the left-hand side, you have your tree. Now, because we're in a simulation tab in the bottom here, right, we split up our feature tree between SOLIDWORKS CAD and SOLIDWORKS Simulation. I go to the Model tab, that's my general CAD interface. I open up my study. Now, Simulation and CAD is sharing that tree over on the left-hand side of the screen, right? So I have my CAD up top, simulation down in the bottom, and I'm going to do a lot of the work here through this feature tree, the simulation tree it's called. And it's very simple to do a SOLIDWORKS simulation FEA. It's a couple of steps, and I like to think of it as starting from the top and working down through the tree, hitting each one of these options one by one so that I can set up and run my study, right? So step one, step 2, 3, 4, 5. Okay, so let's run through these 5 steps and talk about each one of them. Up top is the material. What we see is the name of the part. If it were an assembly, there'd be multiple parts underneath it in a nice hierarchy, a tree structure that we're used to seeing. So this is just a single part, single body. We're not going to get too crazy. There's some other options where I can define the type of mesh element that's used. I can do some different things with the body, how I want to treat it, if it's a remote body, if I want to exclude it, things like that. That would all be set here in step 1. But we're going to keep it very basic, very simple, straightforward here. I right-click on it to get my options. That's what we're going to do as we go through these one at a time. We just right-click on it, and then we get a menu of options that we can pick and click on. So I right-click on the first line item here, the name of the part, and I know I need to apply the material. So edit/apply material, and now I get my SOLIDWORKS material database. If, for example, you applied these materials at the SOLIDWORKS CAD level, they'll be going into simulation automatically populating that. So that's a good way to highlight the integration between CAD and FEA here. This is the generic SOLIDWORKS material library that we're used to seeing day in and day out as we build our assemblies, build our parts and models. Except one difference here is if you click on these, you'll notice that all of the line items here in the materials are not black. Some of them have different colors, red and blue, for example. The red, that means it's a material property that's required. And the blue, that means it might be required depending on the type of study you're using or how it's loaded, right? For example, take a look at thermal expansion coefficient. That might be necessary if I apply a temperature loading to this. If I don't, then it's not necessary, right? So that's the difference between the red and the blue material properties here. I can do something with aluminum, right? I can go down here and scroll through my library of aluminums here, 651, or 1020 steel, 304 stainless, things like that, right? Hit apply, close. Now I know I've done this because I get a check mark on it, right? So let's check that option off the list. We did step 1. Let's move on to step 2, and that is the connections. So connections, that is how the part is going to interact with everything that's around it, not modeled, everything that is around it that is modeled, right? So if it's multiple parts, if it's an assembly, if you have multiple bodies in your part, right? So it's how it's interacting with everything in your model, okay? In the model. It could be things like springs or pins or bolts, welds, things like that. That's where you set this up here. But this is just going to be a basic part. We're going to hold it on one end and pull it on the other and nothing more. So I can skip that step. Next, I have my fixtures. So fixtures here. Now fixtures, that is how it's held in place or how it interacts with things that are not modeled in here, right? Connections is how it interacts with things that are modeled in our assembly. Fixtures is how it interacts with everything else, right? How it's held in place, things like that, right? So again, we right click on it, we get a menu, then we start picking on certain things. So I'm gonna pick fixed geometry. That's just basically holding it in place, completely rigid, holding it, no movement whatsoever. It's the simplest of the fixtures, right? We have more advanced type fixtures too. I can click on down here, like using symmetry, reference geometry. That's a really popular one if you want to specify what we call prescribed displacement, maybe pull on it an inch or push on it or twist it a little bit. You can start using reference geometry. But I like to get started here with the standard fixtures, right? Just using fixed geometry. Now, very similar to how we work in SOLIDWORKS, I have this box here where I pick faces, edges, vertices. This is all stuff that we're used to using here at the SOLIDWORKS CAD level, right? So I click this, I see the green arrows now on my model, letting me know that it's going to be the fixture applied. I hit the check mark, and there we go. So now it's held in place, and next I want to add the external load. How do I know that that's the next thing in my list of stuff to do? Well, I just look at the feature tree, right? 1, 2, 3, 4. Next down the list is external loads, okay? So I right click on that external load. I can apply a force, a pressure, a torque. A lot of stuff we can do here, but to just keep it pretty simple, I just click force, and I'm just going to pull on it, right? Now, I can click on a face, and then it's just going to be normal to that face, or I can pick a selected direction if I want to apply the force on that face, but then maybe push it up or slide it down, right? Go at an angle, things like that, right? But normal to is the easiest one, straightforward. Luckily for me, it works out because I have a face, and I really want the force to just pull on it. Now, the key here is to graphically look at the arrows on your model and make sure that you have them going in the right direction. Here I can see that they're not going in the right direction. So I just reverse the direction, and now the arrows are pulling away from it. Before it was going into it, wrong direction, right? So just graphically looking at the arrows, you have to trust in that graphical representation of the direction, letting you know, indicating which way it's going, okay? Because we don't know which is up or down or left, right, top, bottom, things like that. In 3D space, things get a little bit, we'll say, wonky in terms of the directions. So we graphically look at it and verify that it's going in the right direction. So I can switch to my units of English, and I'll say 250 pounds, pulling on it that way. Perfect. All right. Now, The next step is the mesh. Meshing is a very important step here in simulation. And I've used a bunch of simulation tools in the past, other FEA tools, and SOLIDWORKS Simulation has to be my favorite meshing interface. I'll right click on it, hit create mesh to get into the interface, and I'll explain why I like it so much. Really because it's just the simplest of all of them, the best auto mesher, I think, in the industry. And you really spend the time focusing on what you need to do, your modeling, your analysis, instead of manually building the mesh, right? So what we're seeing here is the basic, simplest meshing interface. I could just hit the check mark and go with it like that without seeing any numbers, without seeing any settings whatsoever. And I can trust that it's going to build a decent looking mesh. And in fact, it did. Now, for my advanced users or for people who have more complicated geometry, you can always go in there and you can tweak the settings around to help ensure that you have a better mesh, right? If you need to, right? So how do we do that? Well, I can bump this slider over to the right or to the left. That makes the triangles smaller or larger, right? To the left is larger, coarse, meaning bigger triangles, mesh elements, or to the right, fine, smaller triangles. Now, I know I'm calling them triangles because they look like triangles, but technically they're tetrahedrons, right? A three-dimensional triangle. Think of a pyramid, but instead of a square base, it's got a triangular base. So it's a three-dimensional shape called a tetrahedron. And I'll get into this just to touch on some of the more advanced topics just so you get exposed to them. But that's not really the point of this introductory video here, right? So if I expand the parameters, I have different algorithms for dealing with the geometry. Standard is the simplest, straightforward. Curvature-based is a really great algorithm that handles more complicated curvy geometry a lot better. See the big difference here is with the standard mesh, you have a global size. With the curvature-based, you have a min and a max, right? Here's the max element size. Here's the min element size. I can give it a 2. So now it has some flexibility to grow or shrink depending on the geometry and the types of intricacies of your shape. And then you have things like the growth ratio. Lastly, we have draft quality mesh. SOLIDWORKS by default meshes in what we call high quality. That means there's 10 nodes in our tetrahedrons. If we check this box to make it draft quality, what that means is that it is now just a node at each point, 4 nodes in our tetrahedron, and that means it's going to be solving quicker, right? It solves the equations at each one of the nodes. So 10 nodes per element or 4 nodes per element is a huge difference in solve time. But by default, it's going to be high quality. So especially in terms of doing basic analysis, you should definitely be using a high quality mesh. So what that means, high quality mesh, just don't check the draft quality box. Simple as that. Okay. So here we could take a look at this and I'll show you what this looks like now using the curvature-based meshing algorithm. And what we'll notice is that there's going to be a lot more elements here around the center. It's got this curved area. So instead of it being just really nice looking triangles like here, nice and straight and squared up, they get a little more organic looking because it's fluctuating the size to make it go from that larger rectangular face to the curved geometrical area. Now, the last thing I want to check is if this is a good mesh or not. How do I know? Well, it's as easy as right-clicking on your mesh, hitting details, and then you get your mesh details up here, right? And this is what I look for here in my mesh. It's percentage of elements with aspect ratio less than 3 or greater than 10. If this is a 0, that is definitely a good mesh. And if this is very, very high, like 99.8, that's a really good mesh. Aspect ratio has to do with the shape of your tetrahedron. You want that number to be low, right? It's the ratio of essentially the base height. It's a little bit more complicated than that in 3D space, but you can think about it in that way. And it basically says it is a nice, good shaped tetrahedron that's going to perform well and give accurate results. So you want to make sure this number, the aspect ratio less than 3, is very high. and greater than 10 is essentially 0. That's what I look for. And that's how I know with hard numbers, quantifying whether or not it's a good or bad mesh. Okay, so that's all you need to know about for that, especially in the context of an introductory study. Okay, so I hit all of my marks, right? Step 1, 2. We skipped step 2, right? Step 1 was the material, 1020 steel. Skipping step 2 because simple part. Step 3 was the fixture, holding it in place. Step 4, external loads, pulling on it with our force. And lastly was the mesh, setting up our tetrahedron solid elements here. Okay, so we can run the study now. And the thing is, this might take a couple of seconds to run. So I hope you guys got some benefit out of seeing how to set up your study, right? It's just 5 steps. Start at the top, work your way down. It's very simple. We rely on the auto mesher, right? That's one piece of advice. And then the second piece of advice is to look at the arrows representing the loads and the fixtures, and trust that the graphical representation of them is going to be correct, okay? That's how you verify the direction of your force, right? Positive, negative, things like that, okay? So let's get back into this here. I have my results now, okay? So my results by default are stress, displacement, and strain. I can look at the stress. Here's what I got. It's in pascals. Here's my displacement in millimeters, okay? Now maybe I might want to change around some of these settings here. So I could right click on it and hit any of these options here to get into the settings to change around the colors, the scaling, the result type, the units, scientific notation, things like that. Okay, so I see my color chart here. It's in scientific notation. It's in pascals. I'm not a huge fan of that here in simulation. So what I did was I double clicked on that color plot, and now I can change this around to floating. So I just get the numbers. Okay, great. Now it updates graphically. If I go to the definition of this, I might want to know my von Mises stress. Obviously, you can change it to principal stresses or shear stresses or anything like that. I might want to know it in PSI, for example. Right, we're here in the United States. I'm in Florida. I'll use PSI for my plot. Okay, so I can change that. And I know the yield strength is 50,000 or 50 KSI. And we're seeing only 600 PSI. That's pretty great. If I look at my displacement plot, again, millimeters, scientific notation, not really that helpful, right? So if I go into my options here for the plot, I can change around these settings, right? I want it to be floating. And you know what? I also don't want it to be in millimeters. I want it to be in inches. And it's not even registering, right? But if I animate this plot, what I'm seeing is that it definitely looks like it is being stretched out and changing its shape. And I'm confused. What the heck's going on here? Well, it's because of this deformation scale, right? It's, this number that's shown here, it's being exaggerated 14,000 times. That's crazy. So that's why the displacement is not even registering on this model. And, it looks like it might be. Okay. So, the only other thing that I might want to do here is some other plot tools I can show you, right? If I right click on the plot that I want to look at, I can start probing. This is a great tool where I'm on location, right, at location, and I just click on a particular face, that point then, and it picks up that node. And what's great about it is if you click in an intelligent way, like I'm going from top to bottom, I can just plot it as is by clicking this plot button. And I can see how the stress increases or decreases as I click through here. Okay, so I'm seeing, an area of low stress right in there. So some interesting stuff we can do there. I could look at things like the reaction forces. That would be by listing the forces here, list selected. But what I want to show you is the section clipping so that here I can start to do a section view on my plot, okay? So for those of you who are SOLIDWORKS users, what you'll see is the section view button doesn't work in SOLIDWORKS Simulation. It's because it's a graphical representation of a really complicated set of equations that represent the results, right? So you can't use that, the generic section tool inside of SOLIDWORKS, okay? So I'm going to change this around here a little bit so that you can see it. So this is my section view here, right? So now I got this good looking plot. I can look at it there. I can do an ISO clipping that will isolate values, show me all the values above or below a certain value. That could be very useful for us. But here's a piece of advice for some more experienced simulation guys. I get this all the time. They don't know how to turn this off. Once it's on, right? So what I need to do is go back into section clipping and scroll down to the very bottom. And I have this button here with no text next to it, just the tooltip after I hover over it, saying clipping on or off. Make sure that's turned off, and then the section clipping is turned off. All right, so pro tip there, that's how you can turn them on or off, okay? Then one more plot here for you guys called the Design Insight plot. What the Design Insight plot does is it shows you areas of high stress so you can see where it's loaded the most, right? If I move this over to the left, here's the highest stresses, and then to the right, I can start to see, okay, that's the area that is definitely carrying a lot of the load. So I can look maybe to remove some materials, some of these areas where it's not, showing that. And that is a quick look at SOLIDWORKS Simulation. I hope that was helpful for you guys. What we did was basically just took an introductory part, the simplest part that we possibly could. And I just wanted to share with you guys how to get started, right? Some tips there as we went through it, but basically just the setup there, okay? Look for some future live streams where we'll go through some maybe more advanced things, some tips and tricks, and we're definitely going to talk about some of the other SOLIDWORKS products, okay? So with that being said, I'll sign off here. Thanks for attending, guys. I appreciate your time.